Hello, everyone. I'm representing Group 90. Our topic is accurate stereo matching for depth estimation using convolutional neural network. So, motivation, why accurate stereo matching matters. Depth estimation is used in a lot of applications like mobile robotics and ADAS systems, where it forms the first step for a lot of tasks like obstacle detection, 3D reconstruction, and scene understanding. Now, traditional approaches, signal processing based approaches, struggle with textureless regions, occlusions, and varying lighting conditions. This leads to inaccuracies in the depth maps, a lot of glitches in the depth maps. Now, the role of deep learning is that it can learn complex features and relationships and perform much better than these conventional techniques. Now, the problem statement is you have two images captured from two cameras simultaneously, and given a pixel in the first image, you're trying to find its depth using the second image. So our proposed solution is a convolutional neural network. And as for the data source, it's the Kitty stereo dataset, which is part of the Kitty Vision Benchmark suite, which is designed for autonomous driving. So it is very suitable for um, our problem statement. For the input-output descriptions, you will usually have two images like seen on the first on the left side, and you have a pixel for which you want to find its depth. Now, on the right side image on that scan line, the correct pixel could be anywhere. This calculation is known as the disparity. Once you have the disparity, you have the relationship between disparity and depth, which allows you to calculate depth. So the more the shift, the farther away is the image. Um, so you want to find similarities. That's what a cost usually does. So this would be a traditional approach would be to use a sliding window, as seen in this diagram. You would calculate a cost volume, which all methods do, and aggregate over all the pixels in the image. Finally, use an optimization to get disparity values once you solve the cost and convert those into grayscale values where lighter shades represent objects which are closer to the camera and darker shades represent objects that are further away from the camera, as you can see on the right here. You can also use a heat map. This is one of the many representations for depth. Now, our evaluation procedure and metrics, we're using accuracy, precision, recall, and the F1 score, which are suitable for something like convolutional neural networks. Accuracy measures how often the model predicts there is correct disparity. The precision measures how many of the predicted values were actually correct. The recall reflects the model's ability to identify all relevant disparity values, and F1 score balances both precision and recall into a single metric. So the baseline model, we've gone over this in the past, is the semi-global matching algorithm. Now, it's a traditional, highly rated signal processing based algorithm for depth estimation, and it makes use of mutual information. As for our model, it's a CNN for stereo depth estimation. As seen on this slide, we have several layers, convolutional layers, and a ResNet, and then a softmax layer. So it'll do the feature extraction, and that will form the basis for accurate stereo matching. Now let's look at the results. So this is just for visualization. Um, the images on the top left are the actual images. Now the image on the top right is the ground truth. Um, the image, so now as you can see, the traditional method suffers from a lot of these glitches. The map is not smooth and the objects are not well defined, whereas the CNN outperforms it. So this is a visual representation of the performance. Now, as for the results um, the, of the metrics, we have drawn a comparison here based on the data set, aggregating over all the different values in the data set. As you can see, our model outperforms the traditional approach uh, in all four of the metrics. So there's a substantial performance gap. Our model outperforms the base model. These are our references. Thank you.